One word connects our bodies to industrial machinery. That word is capillaries. Let's explore this. Sounds like a strange question, right? But the answer shows a surprising parallel in two completely different worlds. That's the link right there. So let's see how these systems work and what happens when they fail. First, we'll explore the tiny pipes inside us. Then, we'll check out their industrial counterparts. All right, let's dive in. In our bodies, capillaries are the absolute tiniest blood vessels, making up vast networks. The walls are lined with something called the endothelium. It's basically a super selective gatekeeper. But this barrier isn't the same everywhere. Some are really tight, while others are porous by design. So the key is controlling what gets through. When you lose that control, the vessels start to leak. Basically, fluid starts squeezing through the gaps between cells, gaps that are supposed to be sealed tight. A key culprit here is a protein called VEGF. Its signal literally pries the junctions between cells apart. And this is no small problem. This leakage is a key part of serious diseases, from cancer to blindness. Okay, let's switch gears. Now we're leaving the body and stepping onto the factory floor. Here, capillary tubing connects pressure gauges to the main process. It's like a remote fluid line. Why do this? For safety. You move the delicate gauge away from anything dangerous or hard to reach. But these tubes aren't perfect. First, temperature changes make the fluid inside expand and shrink. A big temperature swing can create a false reading of about half a psi. That's a critical error. Next issue? Elevation. The fluid's own weight creates an error depending on the gauge's height. If the gauge is higher, it reads low. If it's lower, it reads high. You have to zero it out. And finally, there's a lag. The gauge doesn't respond instantly to pressure changes in the system. And the definition of this lag is really specific. It actually accounts for the system's physical limits. What causes the delay? Basic fluid dynamics. The longer and thinner the tube, the slower it responds. And here's the big takeaway. Both are tiny transport systems where failure has massive consequences. So whether in our veins or in a factory, these tiny overlooked tubes are absolutely vital. It really makes you wonder, what other invisible systems like this are critical to our world?